This is Cambridge IGCSE Chemistry, Paper 6, Alternative to Practical, specimen paper for examinations from 2023. Question number 1. A student investigates the rate of reaction between magnesium ribbon and excess dilute hydrochloric acid by measuring the volume of gas produced. The student uses the apparatus in figure 1.1 to do two different experiments. A. Name the items of apparatus labeled X and Y in figure 1.1. Now, X is a conical flask. And for Y, it's actually what is this? This is a measuring cylinder, but inverted. All right, moving on to B. The gas made in this reaction is hydrogen. Describe how the student can test that the gas is hydrogen and give the expected result of the test. Now, hydrogen gas, you should use the top test. Right, you use the lighted splint, bring it to the mouth of the test tube, and then it should leave a squeaky pop sound. Moving on to figure 1.2 shows the results for each experiment. C. Use figure 1.2 to determine the total volume of gas made in each experiment. So if you look at the axis, the y-axis represents the volume of gas. So you just need to be able to read from the y-axis. So experiment 1 gives you 80 cm cubic centimeters. And then experiment 2 gives you 40 cubic centimeters. Quite straightforward. Moving on to 2, use your answers in C1 to suggest what the student changed in experiment 2. Now, if you know your theory well, experiment 1 has a taller graph, right? Produces way more gas than experiment 2 because it's using more reactants, right? Because more reactants generally translates to more products. So the person is using more reactants, right? So in the context of this question, he's using more magnesium mass, right? So this one is comparing to experiment 2. So in terms of experiment 2, it's using less magnesium mass, right? So follow the question. The question is asking for experiment 2. So experiment 2 is due to the student is using less mass of magnesium. All right, specifically, if you look at it closely, it is half of the mass. Moving on to the next question. On figure 1.2, sketch the curve expected if experiment 1 is repeated using magnesium powder instead of magnesium ribbon. All other conditions remain the same. So we know that by using powder, other than ribbon, it will lead to a greater rate of reaction. Right, but all other conditions remain the same. You're using the same mass of magnesium, which means that the total product form remains constant, which means the same. So all you need to do is draw the graph as greater rate of reaction means that the initial shape will be very steep. Sorry, I'm using an iPad. I can't draw this in a great way. But in your exams, please draw it nicely. So it's way steeper, but the volume at the end is still 80. All right, so this is for question 3. Right, this is question 3. Moving on to 2. A student investigates the reaction between dilute hydrochloric acid and 2 different aqueous solutions of sodium hydroxide labeled solution A and solution B. The student does 2 experiments. Experiment 1, the student rinses a burette with dilute hydrochloric acid, fills the burette with dilute hydrochloric acid, runs out some of the acid so that the level of the acid is on the burette scale, uses a measuring cylinder to pour 25 cm³ of solution A into a conical flask, adds 5 drops of thymophthalate indicator to the conical flask, swirls the flask while adding the acid from the burette to the conical flask until the solution just changes color. Experiment 2. The student empties and rinses the conical flask with distilled water, repeats experiment 1 using solution B instead of solution A. Use figure 2.1 and 2.2 to record the readings for experiment 1 and 2, experiments 1 and 2 in table 2.1 and complete table 2.1. Now let's read. Okay, I would suggest students, if let's say you see your exam paper in separate pages, it's better for you to record it on the page with the readings. Let's do that. So this one is 4.1. This one is 29.5. This one is 16.4. The last one is 29.1. So let's just copy them down. Make sure you fill them correctly. This is initial. This is final for experiment 1. This is initial for experiment 2. This is final for experiment 2. So how to find the volume of acid used? Just minus, right? Just minus. Then you get 25.4, and the last one is 12.7. Right, so those are your answers. All your values should be in 1 decimal place for burette or the nearest 0.05. Okay, but it's easier for you to just put as 1 decimal place. B, state the color change observed in experiment 1. Now, the indicator thymophthalate is actually blue in color if it's with alkali medium. And then once it gets neutralized, it will actually change color to colorless. All right, moving on to C1. State which solution of sodium hydroxide, solution A or B, is the more concentrated. Explain your answer. Well, as you can see, the acid required in experiment 1 is more than experiment 2, which means that A is actually the more concentrated solution, as it requires more acid to get neutralized. Right, so it is solution A is more concentrated than solution B because it requires more acid. Let me just rephrase that with a better professional phrase, which is it requires a greater volume of acid in the titration process. Right, 2. Deduce the simplest whole number ratio of concentration of solution A to concentration of solution B. So as you can see, this is double the amount. So it's a 2-to-1 ratio. Right, concentration of A is double of B, so it means that the concentration will be a 2-to-1 ratio. Moving on to D, state the volume of hydrochloric acid needed if experiment 1 is repeated using 10 cm³ of solution A. Well, back to the... Let's refer back to the question first. Experiment 1 uses originally 25 cm³ of solution A. So, let's just establish that if 25 cm³ of alkali requires 25.4 cm³ of acid. Right, so you can just establish this as alkali acid ratio, which is 25 to 25.4. So this time you're using a 10. So means that it will be, you need to take this value and divide it by 2.5. Right, the conversion factor here is to divide the entire ratio by 2.5. All right, so with that said, you can use your calculator for that. The answer should be 10.16 cubic centimeters, or if you wish to leave your answers as 3 significant figures, it is 10.2 cm³. All right, moving on to E. In experiment 2, the conical flask is rinsed with distilled water. Suggest why the conical flask is rinsed with distilled water, because you want to remove the residues, remove the substances left from the leftovers from experiment 1. Moving on to 2, the conical flask is not dry after it is rinsed with distilled water. Suggest why the conical flask is not dry. Now, this requires a little bit stronger understanding of theory. You see, your conical flask, okay, the number of moles, the number of particles of the alkali, which is, in this case, we're using sodium hydroxide, do not change despite how much water you add into the conical flask. Right, it does not, despite you add more water, but the amount of particles, the number of sodium hydroxide particles remain unchanged. So the neutralization process, okay, will actually not get affected. All right, the water is only an issue if you choose to dilute the acid instead. Right, which means that you need more volume of the acid. But in the case of the conical flask, every pieces of sodium hydroxide, the amount is not changing. The concentration is dropping, yes, but the amount is not changing. So technically, it won't affect the volume of acid required in this reaction. Right, so it does not change the amount, but let's be specific, the moles of sodium hydroxide. All right, moving on to F. State the effect, if any, on the volume of dilute hydrochloric acid used in experiment 1 if the solution of sodium hydroxide is warmed before adding the dilute hydrochloric acid. Give a reason for your answer. Well, heating, as again, does not change the number of moles in a conical flask. Right, the number of sodium hydroxide is still there. Okay, it's not changing at all. So there will be no effect. Why? Because temperature does not change is exactly the same answer, you see. All right. So it does not change the amount or mole of sodium hydroxide present. Moving on to G1, suggests how the reliability of the results from experiment 1 and experiment 2 can be confirmed. Repeat the experiment and compare the results with each other. Right, you do repeats and then you compare them with each other and see if there are any anomalous results. Right. 2, suggest a more accurate method of measuring the volume of the solution of sodium hydroxide. Now, if you look at the question, the sodium hydroxide is actually measured using a measuring cylinder. Despite it is easier to use, easier to operate, but it's not having the best accuracy. It will be better if you choose to use a volumetric pipette. All right, or burette, actually. Now, H, aqueous sodium hydroxide reacts with aqueous barium chloride to form a white precipitate of barium hydroxide. Using this information, suggests a different method of finding out which of the solutions of sodium hydroxide, solution A or solution B, is more concentrated. In your answer, state how your results show which solution of sodium hydroxide, A or B, is more concentrated. This is a precipitation reaction. We haven't changed the sodium hydroxide just yet. So you can actually use barium chloride as a measure, of which one is more concentrated by looking at the precipitate. Right. The idea is that, let me just write the equation real quick. The more concentrated sodium hydroxide is, given that you have two solutions of the same volume, it will mean that the amount of hydroxide ions available is actually more. Right, more concentrated, given that volume is constant, means that the amount of sodium hydroxide is actually greater, which leads to more formation of barium hydroxide. So how can we plan an experiment out of that? We can just use, well, essentially the mass of the barium hydroxide form. Right, so let's start with, as usual, planning experiments. Make sure you know your variables. The dependent variable here, as we mentioned, is the mass of precipitate form, which allows us to determine the concentration, which is the conclusion of the experiment. Our independent variable is actually just A and B, and our control variable, our constant variable, is just the volume of barium chloride used and also sodium hydroxide, because we want to be as fair as possible. So with that said, let's mention, first of all, let's use equal volumes of A and B. Then we add the same volume and concentration of barium chloride, and then we measure the mass of precipitate form, right? Which is actually, you need to filter, of course, because it's a solid, right? From the remaining aqueous substances. So you need to filter it and then essentially do the wash, dry, and then measure the mass. Okay, but this is a 3 marks question. I don't think you need to mention like as, too detailed, unless this appears in the last question, 6 marks. So with that, how can we prove that? the mass of precipitate correlates to the concentration. So the more concentrated solution will lead to a better, or should I say a greater, mass of precipitate. Right. Yeah, pretty much that's it. All right. So if you want to make sure that you are able to plan the experiments well, list down your variables. It makes things clearer. Okay. Moving on to question 3. A student tests on two solids, solid C and solid D. So test on solid C. Solid C is iron 2 sulfate. Complete the expected observations. The student dissolves solid C in water to form solution C. The student divides solution C into 3 portions. A. To the first portion of solution C, the student adds 1 cm³ of dilute nitric acid, followed by a few drops of aqueous silver nitrate. The keyword here is silver. Silver reacts positively with halide ions to form silver halides. Now, by this question, there are no halides present. No halides, meaning no change in the observation. Moving on to B, to the second portion of solution C, the student adds 1 cubic centimeters of dilute nitric acid, followed by a few drops of aqueous barium nitrate. Now, similarly, the keyword here is barium. Barium reacts positively with sulfate ions to form a white precipitate, which is barium sulfate. So, is there sulfate present in this solid? Absolutely. There is a sulfate ion here. So, means that you will form a white precipitate. Moving on to C, to the third portion of solution C, the student adds aqueous ammonia dropwise and then in excess. Now, this is alkali cation test. So this one will react positively with iron 2 ions, not the sulfate ions, but the metallic cation. So iron 2 is green in color. So it should form a green precipitate. Then we have to mention the second part, which is in excess. Does it dissolve or not? So it is insoluble in excess. You can check the table in the cation test table. Okay, you can check the cation test table essentially to check your answers. Moving on to the next question, test on solid D. Table 3.1 shows the test and the student's observations for solid D. For test 2 and test 3, the student dissolves solid D in water to form solution D. The student divides solution D into 2 portions. Test 1, do a flame test. And it exhibits orange-red color. So what exhibits orange-red color under flame test? There will be calcium ions. Moving on to test 2. To the first portion of solution D, add aqueous sodium hydroxide dropwise and then in excess. There is white precipitate and no further change. So this tells us that it is a non-transition element. Okay, this is also a cation test, alkali cation test. So no change. Sorry, what I mean is, it's similar to the ammonia question just now. So it is not a transition element because it doesn't form a colored precipitate. Test 3, to the second portion of solution D, add 1 cubic centimeters dilute nitric acid, followed by a few drops of aqueous silver nitrate. The keyword here is silver. So silver reacts positively with, as mentioned, halides, right? And then specifically, what is the white precipitate? Chloride gives white precipitate when it reacts with silver. So describe how to do flame test used in test 1. Oh, okay. For this one, it requires a little bit of laboratory experience. You will need to use a clean wire and then essentially somehow like scoop the solid with the solid sample. And then with a, using blue flame, okay, from Bunsen burner. And then essentially you put the wire into the flame and then observe the color. So pretty easy. You just take a wire, put the solids, like silvery gray solids, and then essentially place it like under a Bunsen burner. Right, and then just place it and then see the color. Okay, so essentially there's a setup. E, identify solid D. So as mentioned, it is just calcium. All right. All right, moving on to the next question. 4. The label on a bottle of orange drink states contains no artificial colors. A scientist thinks that the orange color in the drink is a mixture of two artificial colors. Sunset yellow E110, Allura red E129. Plan an experiment to show that the color in the drink does not contain these two artificial colors. Your plan should describe the use of common laboratory apparatus and samples of E110, E129, and the orange coloring from the drink. You may draw a diagram to help answer the question. Well, as you can see, this question heavily talks about pigments, colors. What's the first thing that comes to mind? Chromatography. Right, the first thing that comes to mind is chromatography. And then, in fact, chromatography gives you the first mark. So let's plan our chromatography. Similarly, list down the variables first. Technique, the independent variable, the dependent variable, and also the control variables. Actually, this question doesn't... Actually, yeah, you can pretty much control other things such as maybe how you place the dots, how you place the spots, right? And then with the same origin. So this question doesn't exactly have the best, like obvious control variables. And maybe talk about intensity of the spots, and then many more. Okay, let's talk about independent and dependent variable. Independent variable will be these three solutions: the orange drink, the sunset yellow, and also the Allura red. And then dependent will be the position or the retention factor. Right? So the setup pretty much is take a piece of paper, place the three spots, the orange, the yellow, and also the red. So make sure that they must start on the same line. So these are the baselines. Use the pencil and draw a line as the baseline. Okay, and then immerse it in a appropriate solvent, right? And then run the chromatography, right? Run the chromatography. So with that said, let's just try to figure out the marks. So the first mark is chromatography, and second is use a piece of paper, chromatography paper. And then you can draw a pencil baseline / origin. Then with that said, you apply the 3 colors, which is list down the 3 things, which is the orange drink, the Allura red, and also the yellow. Okay, make sure you write in full, yeah. Don't be like me. I'm just writing it as a rough idea. Okay, and then you can talk about, well, how you immerse the paper. You must make sure that the solvent is below the baseline. And then you allow the solvent to travel up the paper. And then you can use a ruler to measure the, so 2 things that you need to measure, which is one is the how far does the color spot travel, right? The first one is to measure the distance of the color spots. Okay. The second is the solvent front. Okay, the solvent, how far does it travel? So the solvent. Okay, and with these 2 things, with these 2, essentially the 3 spots and also the solvent front distance, you establish the RF values, right? So you can actually make your conclusion from the RF values. So essentially, how do you prove this statement? How do you prove that the orange drink does not contain, okay, the red pigment and also the yellow pigment? It's just they have different RF values. So neither, like, it doesn't, like, it's not parallel with the other 2 spots. See, like this one, for example, this is just an example. The orange may have traveled further, and then the yellow stops here, and then the red stops here. So orange travels here means that it does not have any pigments, right? That is comparable to these 2. Okay, so essentially you can use the RF values and then establish that it does not contain these 2 artificial colors. So that's pretty much it. As you can see, there are more than 6 points. Make sure that if you want to score all the marks, make sure that you write more than 6 points. As long as your concepts are correct and then your variables are in good control, then you should be able to get full marks. Okay, any other points include also like precautions that can also lead to marks as well, right? How we immerse the paper in the solvent. So I hope that with this rough planning, it helps you in writing your experiments. Okay, so that's all for this paper. Thank you so much for watching. I hope that it really helps you in the exams, and also, well, I hope you're able to score very well. Okay, so thank you, and I'll see you in the next one.